All right, so today we're going to get started on a project that I think will last a few lessons, and I'm kind of excited. I have not done anything quite like this before, and we're going to be animating a caterpillar. So there's going to be a few different components to this, but you can break them down basically into, there's going to be modeling tasks and animation tasks. And so the modeling that we're doing, some of it will just be expanding our toolkit to make it more sort of robust and modular from what we have currently. But we also will be doing our modeling to ensure that we have the data we need in the mesh to do this animation in the vertex shader. Because remember, as we did last time, we really made a lot of use of this V texture coordinate, or really parametric coordinate of the model. And so we're going to be doing similar things, but with a more complex mesh and a more complex animation. So we have to make sure that we're modeling for this animation. So before we get started with improving our modeling toolkit, which I think we'll do today, we'll make some changes to the tools as well as modeling the base shape of our caterpillar. Let's get sort of an overview of what this caterpillar is going to look like. Okay, so it has sort of this cigar-like shape to it, and then the body is sort of segmented. And in the back, there are these structures that look almost like legs, though I've been informed through my research that these are not actually legs, but you'll see they sort of serve a leg-like purpose. And then up front, there are the real legs of the caterpillar. And so it has sort of this different style of motion in the front and back, which will be interesting to animate. And then also you'll see there's this kind of like rear wheel drive aspect to this where it's driving the motion from behind. And then let's just put like an eye here so you can see, right? It's facing this way, though I don't think it actually does have an eye there. Okay, so that's kind of what our caterpillar looks like. And I should also say, you should definitely check out this video. I'm going to link in the description, which is a really cool reference that I'm going to be kind of basing this animation off of. So definitely check that out. All right, so I think today let's just focus on modeling this base shape of the caterpillar. Okay, and then in the future lessons, we'll start looking at these pieces that are coming off of it, because there's going to be more modeling and more animation concepts that come into play for these sort of more secondary pieces. Okay, so let's today focus on improving our modeling toolkit and making that more modular, and then let's look at creating this base mesh. So I've got our caterpillar scene set up here, and I've got a tube on it for now, but I think we're going to do some work on this and not use this tube anymore and try to make this more of a general purpose modular parametric model script. Like, for example, this radius curve that we threw onto this just to demonstrate what you could do with it. I think this would be nice to have as like a modifier that you could add to this object, but it wouldn't necessarily be part of the base parametric model. Okay, so that's one of the things I want to change. I think we want to be able to have stackable modifiers and not just this curve, but other things. Okay, the other thing I want to do, and maybe let's come back to the whiteboard and start illustrating this. Okay, so if you think back to our parametric modeling lesson, we sort of have these two different parameters that are controlling our shape, right? So we've got our U coordinate, which kind of is circling around this circle here. And maybe I'll just put this in different colors or something like that so you can see. Okay, we've got our U coordinate, and then we've got our V coordinate. But the things that are being controlled by these U and V coordinates are these sort of hard-coded functions right now. It'd be useful to be able to change those, as well as being able to add sort of like stackable modifiers. So as we're changing our parametric model script, let's think about ways that we can make this customizable going forward. All right, so I think we're going to use a few different scripts here. So let's create a folder. I was going to say parametric folder. Parametric modeling. Okay, and then we'll create our base parametric model. And let's just copy over the tube to start with. So I'll copy the tube script. Let's paste that into the parametric model, and let's make sure that it's called parametric model. Okay, so that should be working fine. Now, the first thing I want to do, again, like let's get rid of this radius curve. Okay, this will not be the way it works. And let's do the modular aspect of it first. The fact that we can add kind of stackable modifiers. So, I mean, right now I just deleted that curve, but it would be nice to be able to still use it just as a stackable modifier. So I think what we can do, and let's come back here and make sure this compiles. Okay, so I think what we can do is, let's create a new model behavior, and we'll just call it parametric model modifier. And we can declare this as an abstract class. And what that means, if you're not familiar with it, is that you can't create any instance of an abstract class directly. You have to have something that inherits from this class that will then implement the abstract methods in order to be able to actually instantiate that class. Okay, so what is the abstract method that I'm talking about? Let's create one now. So we'll say public abstract vector3, let's say, and we'll say get modified position. Okay, so we'll throw an input position here. We'll call it input pause, and then let's also pass in our u and v coordinates in parametric space. Okay, so then I just kind of did that mechanically there, create a body, but you can't create a body. If it's an abstract method, you cannot declare a body. The classes that inherit from this will provide the body for this. And then once you do provide the body, then you can create an instance of that particular type of class. So if you don't really quite get it yet, maybe you'll get it once we create our animation curve example. So let's come in here and create a model behavior, and let's say parametric, we'll call this animation curve radius multiplier. That's way too long, so we'll just call this curve radius multiplier, okay? And then let's actually implement this. So we'll say that this is a parametric model modifier. And then you see this says it's complaining because we didn't implement that abstract method. So let's just click this, implement abstract class. Okay, and then we have not yet implemented it, but it won't complain. So let's now implement it. So let's add our animation curve. We can just call it curve because we have the context of what it means already here. And then remember, we want to take our v coordinate and drive the curve with the v. So we'll say radius mult equals curve dot evaluate v. And then what we can do is return our input position, or we can say input position dot x times equals radius mult z, and then return our input pause. Okay, so that's kind of doing what we had before, but now we have this as a modifier that we can add to the object, and we can create different types of modifiers. And then if we don't want to use this, then we don't have to like go in and initialize every single modifier we eventually want to add to this, right? We're kind of only include the things we want. So this still has a radius curve because it's not our parametric model. So let's remove that and let's add the parametric model here. Let's just build this just to make sure this is working. And we don't have a material on it, so let's just assign a material. Okay, so now it's got like a material on it, and let's just give this some kind of height to it. Let's say 8, build mesh. Okay, so now if we wanted to add our radius multiplier, let's see how that's gonna work. So add our radius multiplier, let's add some value here, and let's build. Nothing happens because we never actually integrated this into the model. So now let's come in here. And what we want to do basically is let's have a array of these modifiers, and we don't want that actually to be public, because what we'll do is when we build the mesh, we'll just say mods equals get components, and we'll get all modifiers that are attached to the same object. And so that's kind of the advantage of using this like abstract class or inheritance generally, is that we can say, you know, nothing's going to be an instance of this exact class, but it will have instances of things that inherit from this, and we can kind of invoke them all just knowing that it's this modifier type. So we come up here, you'll see what I mean. So before we just return that, let's just create our point we're going to return like that. And then we'll just iterate over all of our modifiers. And we will invoke that get modify position, ret uv. Okay, and then we have to make sure that we assign that back there so that we don't just throw that out, and then let's return there. Okay, so let's see if this works. Okay, so now our radius multiplier modifier is working. Okay, so let's just get something in here that's roughly what we want from our caterpillar shape. So we'll just make sure that we have points that are at 0 at the beginning and end, and then we'll kind of make sure that it's sort of at the full radius for most of the middle section. Okay, and then we can say, like, I don't know, like that. And we can make like that. And so let's make sure that these tangents kind of come in more sharply at the beginning and end. And let's see what that looks like. Okay, I mean, that's looking okay. And actually, this is one of the reasons why I kind of wanted to make this more modular, is I do think it's difficult to come up with good like tangents for this animation curve tool. It tends to really come to a point, and you really have to be very precise to make sure this doesn't come to just like a single pointy end here. But we also probably need to add some more V subdivisions in order to get more of a rounded end. And just while we're at that, we can see like right now, all these V subdivisions in the middle, we're not really doing anything with those. Now we're going to, because remember, come back to our template here for what we want to do. Let's add some segmentation to this. So we will do something with that. But just to be aware of, like, there are ways that you can only add subdivision where you need them, but it's a little bit out of scope for what we're trying to do with these lessons, but maybe it could be an interesting like bonus lesson. So I think this is a good start for the base shape. So, and actually what we could do is just rotate this down so it kind of matches what we're seeing in the template that we made on the whiteboard. And so I think what we can do now is start adding that segmentation. Now, we could do something similar to what we did last time, where we were doing some modeling actually inside the vertex shader. But I think just since we're going to be making these models more and more complex, let's try to keep as much of the detail in this actual model. And then we'll keep the vertex shader for just doing the animation part. But one thing that we did use in that vertex shader that we can use here as well is sine waves. So we can use like a sine wave to generate a repeating pattern, and we can use that to modify the radius of our model rather than just this animation curve. So now let's create a new type of modifier that's kind of like doing this, but we can use a wave rather than an animation curve, and we can kind of change some of the properties of the wave. So let's create a wave radius multiplier. Okay, and then we'll inherit from our modifier, parametric model modifier, and let's make sure that we implement the function that's needed. Okay, and so for this thing, I think there's just a few things we need to add here. We should have like a frequency. So this would be like the number of iterations of this wave that we see, modifying the mesh. Then we can also give it like a minimum radius. And I think the multiplier, I think the default, the maximum would always be 1, right? So that we're not just applying some overall scale to it. We could also add like a phase, though we'll see if we actually use that, but I think these are the basic things that we need to have. And let's default this just to 1, and that the other ones should be okay to default to 0. Now let's see, as far as what we want to do with this, let's say our wave value is going to be like a math sine of V, right? But we don't really want to do that. We want to say like a theta that we're going to do some modification to and pass that into our wave. So we'll say like V times math pi 2, because that way we'll see like a full repetition or cycle of this wave, which I think will be good. Actually, let's just come over to the whiteboard and see what we're trying to do exactly. Okay, so like if you use sine, then here's like our coordinate system, okay? If you use sine, you'll have something like this, where it's going to cross 0, 0. And so when we feed in our theta at 0, we're going to get 0, which is going to be like our minimum radius. I think what might be better is if where we start is going to be at our maximum radius. So we sort of apply no modification at the beginning of this wave. And then if we want, we can change it with this phase. But I think it will work better if we use the cosine is just sort of offset from where this, let's see if I can draw this correctly. It's going to be kind of offset. I don't know if that's actually correct, but you get the idea is that it's going to, this is the important part that is correct, is that at the 0x coordinate, it's going to be at its full sort of crest of the wave. And it's going to come down, and we'll do one full repetition if this frequency is 1. Okay, so we want to multiply in our frequency there. And then as far as the phase goes, let's do it this way, where we could actually offset this theta by our phase times math pi 2. I think we want to apply the phase after we multiply in this frequency, because otherwise I think it's going to be too difficult to control. Okay, so then let's put our cosine here. So now we've got our wave value. Let's also transform that to 0 to 1 range. And then we'll say our radius multiplier is going to be, let's lerp between our minimum radius multiplier and 1 by our wave value. And then we can take our position and multiply in our radius multiplier. And then let's return our position. Not that. Okay. So let's see how that works. Come back here and let's add that wave radius multiplier to our caterpillar mesh. Okay. And let's give this like an 8 frequency. And for our minimum radius, let's do something that's kind of large. We don't really want to carve into it too much, but we'll see something like that. That's pretty good. We could probably go a little bit more with the radius multiplier. So let's say 7.5. Okay, and then let's even increase the resolution on this too, so we can see a little bit better. We can increase the U subdivisions as well. Maybe not that much, but for good measure. Okay, so yeah, this now what I'm seeing here is like, this is a very even, obviously sine wave looking thing here, which is cool, but that's not really what we want to get out of our caterpillar. Okay, we want to see more of this profile generally, and then we'll just have little dips for where the segmentation happens, but we don't want to see this sort of even sine wave looking thing like that. So I think this is a perfect opportunity to use our easing that we talked about last time. So let's grab that from our grass shader, and I'm conveniently hovering right over that, and let's throw that in here. And so then, and let's just make sure that this is valid C#. Okay. And so before we add in our radius multiplier here, we've got our 0 to 1 range. Let's just apply the easing here. So we'll have to say like which ease function to use. So we can just say ease out like that, I guess. And then we can say ease pow, and let's default that to 1, which will make no changes. So we'll say wave value. We can say if ease out, then do this ease out function on our wave value with our ease pow. Let's make sure that we actually assign that back to the wave value as well. And then otherwise, ease in. And I think this is the perfect example to actually show that ease out, which we never got to use in the last lesson. So let's see. So let's use the ease out, and let's say 4. Okay, build mesh. Okay, that's looking pretty good. I don't really like how it comes down to, like, we're sort of in between segments here. I didn't think that was going to happen. I kind of didn't think that was going to happen because we were using cosine. So let's see if we add our phase, does that change anything? Okay. Yeah, that's kind of more like what I wanted to see. Interesting. Okay. I don't know whether we should keep debugging that. I mean, because, you know, that did work. That is a little curious, though. Maybe you can sound off in the comments if you know why that was happening there. I think now this is too deep, though. It looks like a too deep segmentation. Okay, that's looking pretty good, though. That's looking kind of more like what I want to see. And maybe there's too many segments, so let's dial that back to, like, let's try 6. But I think this is generally what we want from the caterpillar. The one thing I do think might be good is if we sort of make this less of a round profile shape. So right now it's just taking this circle and it's extruding it. What if it was something that was more of an eye type shape that we were extruding? Okay, and so we could even use this same animation curve here and like mirror that and use that as our extrusion profile. I don't know if it would look quite right, but it would be interesting. So we could even we could save that as just like a preset here. And then let's try to get that working before we wrap this lesson. Because I did say we wanted to be able to change these base shapes and paths here. So let's come in here and say, we'll have a parametric model base shape. And we're starting to collect a lot of scripts here. Let's just start putting these in folders. So we'll say modifiers. And let's take all the modifier related stuff and put it in there. And then we'll say our base shape. And we'll put our base shape in here. And so basically what we want to do with the base shape is we'll make this another abstract class, and we'll get base position, let's say, and we can give that our UV coordinates. Because there's going to be no base position to modify in this case, we'll just give it UV coordinates. And again, don't declare a body. I don't know why I keep on doing that. And this needs to be abstract because it's inside of a abstract class. Okay, so we've got our base class for the base shape. And so now let's create the curve, animation curve version. So we'll say curve base shape. So I think what we want to do, let's just go back to the whiteboard here and see. So for our U, we started over here and we kind of wound around counterclockwise. Let's just keep it for consistency. Let's make sure that it works the same way. So our animation curve, though, starts kind of here and it ends here. And it's just going to be, let's say, the top half of this. So what we want to do is, if our U coordinate is between 0 and 0.5, we kind of want to go backwards on the animation curve. And then if it's between 0.5 and 1, we'll go forwards on the animation curve. And then we'll kind of like mirror that on the y-axis. And the other thing that we have to just make sure of as we're doing this is that, remember, our circle is centered at the origin and it goes all the way to -1 to +1 on each of these axes. So it's a little bit different than our usual setup where we like to keep everything between 0 and 1. So that's just something else we have to keep in mind. Like, let's make all of our base shapes kind of work the same way. So now let's implement this. And so actually right now we're not inheriting from our base shape. So let's make sure we inherit from this. And this is going to now complain, and we can implement our abstract base class. And so let's declare the animation curve we want to use. Okay, so the structure of this, we're going to do something different if U is less than 0.5, and then if it's greater, we'll do something else, right? So have kind of like a structure like that. And so I think the U value, we can determine what the X coordinate is directly from that, but then inside of here, we're going to be changing, this is going to be the Z coordinate. Remember, I mean, we're looking at the XZ plane here. So let's say our Z value will be defined inside the body of this. So in this case, we want to go from 1 to 0 for our u. So let's first multiply by 2 to take us from 0 to 1, and then we can say 1 minus u will take us in the range we're looking for. And we can say our z value will just be our curve evaluate u. All right. Now for this purple one, we want to start at 0, go up to 1, and then we want to flip our z value after we evaluate it. So we'll say u minus equals 0.5. Let's just subtract out that start offset, scale up by 2 to get us to 0 to 1, and we'll say our z value equals negative curve evaluate u. Okay, so now we've got our z values. For the x value, that's just going to be our u, but we have to scale it and make sure that it's centered at the origin. So let's just say u times 2 minus 1 should take us to the space we're looking for. And now let's return x value 0, z value, because remember this 0 is going to be controlled by our v coordinate. It's not our base shape. It's going to be like a path that we're going to extrude along. And before we add our base shape, let's just make sure that we actually integrate this into our parametric model. So let's come into our parametric model, and we can say base shape is something that we're going to get when we try to build the model. So here we can say if our base shape is not equal to null, we could do this after maybe we do our default implementation. We can override it with what comes from the base shape. Okay, so then we'll say our base position is going to be our base shape, get base position, uv, and then we can just say x equals base paused x, y, well, z equals base. This is not exactly the greatest API here, but it will do. Okay, and then we just have to make sure that we also initialize that base position or base shape here, and there's only going to be one base shape, not curve base shape, because we can have other different types of shapes. We want to use this abstract class. So let's see if this works. Let's add our curve base shape, and that's not showing up here. So why is that? I think maybe we forgot to inherit from mono behavior here. Yeah, we did. So let's give that a mono behavior, and hopefully our base shape will show up now as a component we can add. Okay, there's our curve base shape. So let's use that preset we set up, and let's see if this works. Hey, I don't know if it looks great, but it's working. So now we can start like messing around with this and see if we can get something that looks better. Let's make one point in the middle here, and then we can say that the tangents on this point are going to be flat, but then these ones should sort of do more like that. Okay, and so then we'll get sort of more of an eye type of shape to this caterpillar body than a flat up, than a straight up circle. Okay, so I mean that's looking pretty good. Now I think what we want to do really is have this a little bit flatter on the bottom. So let's just make a quick, I think this could be pretty easy to change here on our curve base shape. We could optionally give it a bottom curve, and then we could just say use separate bottom curve. Right, and then here we can just say animation curve bottom curve equals use separate otherwise curve. Okay, and then we can just use that there. And now let's come in here and let's say we'll use a separate bottom curve, and we can save that as a preset. Let's fill that there, and let's just bring this down like that and sort of change our tangents here. Just as an aside, I think it is difficult to control these tangents to make them really rounded at the ends, so maybe we can come in here and do something else other than animation curves, but now we have sort of a framework for how to do that if we want to do that in the future. So let's build this. You can see, I think just the way that we rotated this, we have the top side on the bottom. So there you can see, right, the bottom of this caterpillar is now sort of flatter. Okay, so I think this is something that we'll probably keep tuning this base mesh as we go here, but hopefully you understand some of the things that you can do as far as creating a modular system for doing these parametric models. And we'll continue to expand this toolkit as we go in this unit. So I think that's it for this lesson, and I'll see you next time. We'll start animating the caterpillar.